So today we are going to write about queues and stacks, FiFo, LiFo, talk about what that means in case you don't know, and base both. We're going to try to do an implementation of both. Not today. We write today, we code tomorrow, based on an array list and a linked list. Now, of course, I mean, you could do a first in, first out on a singly linked list, but I don't recommend it. We're going to do our first in, first out on a doubly linked list. And we're going to do a LiFo probably on a singly linked list since we already have those written. And we're going to base that all on data structures that we've already written in this series. Just for fun, just to use them. And it should be really, really exciting. Now, the only problem with me actually basing it on my data structures is that specifically my doubly linked list is using an arc mutex. And of course, there's a lot of performance overhead there. So we might, at the end of the day, it's not that hard to change. We might just base it off of for the performance testing, because I kind of want to do a little performance testing between the two. We might use the studlibs linked list, which is a doubly linked list, and they use unsafe and they use pointers and et cetera, et cetera. So it's pretty fast. So let's maybe start by defining a few terms. So let's see. Now that we have implemented an array list and linked list and doubly linked list, let's use them. How about it? I guess we'll code these since these are actually the name of my types that I used. We'll implement 4 data structures. 4 data structures. Maybe what are we saying? We'll implement 2 variants of 2 data structures. I guess that's more correct. I don't know. 2 variants of 2 data structures. No, that's too confusing. Okay, we'll implement variants of a FiFo queue and a LiFo queue, aka stack, based on both an array list and linked list. Okay, pretty good. I swear they just got I swear they just got a gift. But either way, thanks for the gift sub to Russ Sucks. We'll implement variants of a FiFo queue and a LiFo queue, aka stack, based on both an array list and linked list. Okay, cool. So let's just define FiFo and LiFo real quick. FiFo and LiFo. I don't know why they do this. Why would I want to press enter on a header and still be in header text? Who wants that? Now I'm not? I don't know what happened. Okay, here we go. FiFo and LiFo are acronyms. Simply defining, okay, our acronyms defining the what would be the right word to say this? The order of input and output of a queue. Okay. FiFo means first in, first out. I don't know if we should do dashes there or not. First in, first out. Okay. FiFo technically stands for first in, first out, meaning the first element I put in, the first element put in the queue, doesn't need a subject, will be the first element taken out of the queue. Okay. LiFo stands for last in, first out, meaning the last element put in the queue will be the first element taken out of the queue. Let's see. If we use the common method names of push and pop, we could define the rusty methods for a FiFo queue as push front and pop back, and for a LiFo queue as push back and pop back. Technically, you could reverse all those. Method names. But the point being that you're pushing on one side and popping. Let's see this. That you're pushing. Okay, that's confusing. Let's just say we could define the rusty methods for a FiFo queue as push front and pop back, and for a LiFo queue as push back and pop back. Yeah, that's good enough. We don't have to be too detailed. If you can't understand like the next part of that, then I don't think I'm going to be able to explain it to you. Sorry about that. I mean, I could. I just don't want to. Let's see. Push and pop. A LiFo queue is more commonly referred to as a stack. Okay. Or maybe I should say also commonly referred to as a stack. I think that's pretty good. All right, I think I finished this part. I saw your Wordle redeem purplish. We'll see how I do on that. Let me just see what I'm gonna do for my next section. So we explained FiFo and LiFo just in case. This is a lot of words for something that a lot of people probably already know, but they can just skim it or skip it. It's fine. You have too many points. I imagine you do. Just remind me if I forget. Now that we have implemented, we'll implement a variance of a FiFo queue and a LiFo queue based on both an array list and linked list. Okay, so the next part is like it's dependent on whether I want to, how I want to organize it. Do I organize it by what it's based on or by data structure? Probably by data structure. Probably makes the most sense. So let's just start with a queue. A LiFo queue is also commonly referred to as a stack, while a FiFo queue is commonly referred to as simply a queue. Let's put it this way. A queue without in out defined is can commonly be assumed to be a FiFo queue. Okay. I think that's all fair. Anybody fighting me on this? I think we're happy with this. Queue. Okay. So we're just going to say queue. Let's talk about FiFo queues, which will actually I'll just put it here. The rest of this article will refer to these as stack and queue. Okay. Okay. There. Let's talk about a queue. I don't know if I'm going to keep that sentence, but we'll just pretend I am for right now. Stack and summary. I think that's really all we're going to do. So I think that's good enough. Here, we'll put this really good sentence because, I mean, how am I going to remember what I'm going to write about if I don't say, let's talk about a stack? All right. I think that's good. Let's see. Wordle, huh? Wordle time. Here we go. Live on the internet. I don't log in to the New York Times. I don't believe in them. Okay. Let's try this. Okay. PRO. What's a good letter? I guess we'll do a V, even though it's not a very good letter. Okay, we got an R out of all this. So there's a lot of R's. There's no U's. Is there an I? Oh, wow. I even got the R and O where it is. That is pretty special. But it doesn't have a T. I haven't done a W, but it doesn't have an E. So there's not like roti, Roy, W Roik. No, that doesn't work. Did I do a D? No. Droy. Is there anything besides another D for this sort of thing? Is it really just droid? That would be funny. I could do drool, but that doesn't help me too much. I guess we could do this. I'm just trying to think if there's another Anything better? Sure. Oh, you got to be kidding me. So there's no I, there's just R and O. Okay. There's no D. Huh. This isn't looking so good for me right now. Croon is a word. I haven't used any of those letters yet. No. Okay. So we at least know it's ROO. That's pretty reasonable. I only have 2 more guesses. Shit. Fruce is not a word. That's not how you spell gruel. Wow. I'm not doing so good here. I'm pretty sure this is not a word. Come on. Should be. Crook? No, because there's no C. Is there a word like crook? No. Huh. This one's a little hard. Groom. I'm gonna try this one. I haven't used any of these letters yet. How about it? I even had 1 to spare. I think that's the first time I've actually solved it without chat telling me what to do. I think that might be the first time. Let's be real. All right, 1 second. Gotta send some messages real quick. You did a good job, Purplish. Excuse me. All right. You want Quirtle? I forgot what that is, but I don't like it because it sounds harder. Okay, so Q. Thinking back to maybe we want to talk. Do we want to talk about stack or a queue first? In some ways, stacks are easier than queues because stacks are just taking from one side and off, and so it's more like you can use more things for it. So I actually think I'm gonna reverse these. So let's actually talk about a stack and a stack first. To implement a stack efficiently, we should have a data structure with efficient access. We need, how about this? We need efficient access to a single side of a to the single side of a series of data. Okay. Yeah, it does feel easier, right? Well, I mean, you can do it with almost anything, right? Thinking back to are the array list, aka vec, and Rust's stud lib, and singly linked list we've implemented. Both fit the bill. Okay. Both fit the bill. Here's a stack. So let's implement a stack. Implement 2 variants of a stack. One built on array list and one on linked list. Okay. And then here we will. Looks good. Actually, I'm not going to call it this. I'm going to make it easier on myself. And we're going to call our a simple array stack implementation. Rust. In case you didn't know, we're writing Rust, by the way. A simple linked stack implementation in Rust. Linked stack implementation in Rust. Okay. Looks good. Going to be pretty boring in the sense that they're going to have almost the exact same syntax, but that's kind of the point, is that like I kind of just want to drive home the point that it's really simple, because I don't think people sometimes don't get this. Like if you have already got a data structure, whether it's something you've implemented yourself or it's from the stud lib or whatever, it's really simple to just provide a nice little API on top of it. You know, just wrap it for your own purposes. Only use the things that you really want. Only expose to the outside world the methods that you want other people to have. Of course, that's just like a form of encapsulation, but that's part of what I think is like interesting about data structures. It's not just like, can you whiteboard a linked list? It's, can you know when using a linked list for even something else, like even a, you know, whatever it is, if you need a stack, use a linked list. But you don't have to give them everything that a linked list has. You don't even have to let other people know you're using a linked list per se. So anyway, a simple array stack implementation in Rust, a simple link stack implementation in Rust. Okay. That looks good. And then what are we going to say about it? What are we going to say about it? Is there anything we want to say? I guess we could do a little performance testing. I don't actually know what's good for just like really simple performance testing in Rust. Ideally I could just time like how long it takes to run certain tests It's not perfect, but it's an idea. Time function execution in Rust. Runtime prog on the command line. Okay, that's kind of what I was thinking. Let's read about this real quick. These are the kind of things I want to get out of the way today, so it doesn't bog down the coding stream tomorrow. So we'll just go through this. Something you could try to gather more data. What is the effect of duplicating work in your program, e.g. instead of... Sure. We could do that. Use Criterion or Nightly Bencher. Okay. Criterion looks like a possibility. Statistics-driven micro benchmarking library. Criterion helps you write fast code by detecting and measuring performance improvements or regressions, even small ones, quickly and accurately. You can optimize with confidence. Okay. This looks fine. Dev dependencies, Criterion. Sure. Next, define a benchmark by creating a file, add project benches with the following content. Okay, finally run this benchmark with cargo bench. You should see output similar to the following. This is cool. Yeah, we might as well do this, huh? I think it changed my mind. Like, I mean, I wanted to at least make the decision of what I'm going to use, but I think the code writing part of tomorrow should go like pretty freaking fast. If it doesn't, then there's something wrong with me. And then it will just be like how to benchmark these things with Criterion, right? So I think that would be cool. Yeah. Cool. So we're going to use Criterion to benchmark things. I like it. Okay. Now we have a simple shared interface that we can benchmark to consider performance that we can benchmark. Now we have a simple shared interface, let's say simple common interface that we can benchmark the performance of our array list and linked list. Okay. Oh, that might be nice. We'll see if I get this far. I've also included benchmarks for a stack based on vec and linked list from the stdlib. Yeah, I think this would be cool. For a stack based on vec and linked list. based on a vec and linked list from the stdlib. Yeah, it'll be cool. Yeah, this is great. I'm excited about this. Okay, so now let's talk about a queue. I left the let's talk about a stack. Okay. To implement a queue, we need efficient access to both sides of a sequence of data. So how I said it before, series of data. Okay, that's fine. We need efficient access to both sides of a series of data. Currently, we haven't implemented an array-based data structure that has this characteristic. Hint, hint, that's what we're going to do next. Hint, that's coming next. Hint, hint, you can use vec dec from stdlib for this. Okay. Let's see, hint, hint, or maybe hint 2. There we go. Confusing formatting, always fun. Currently, we haven't implemented an array-based data structure that has this characteristic, but this is a great opportunity to quantify the performance of the degradation of performance by using an array list for a FiFo queue. Okay. I like this. And let's do this. Okay. While the linked list, singly linked list, does not satisfy this requirement, our doubly linked list does. So let's implement 2 variants of a queue. One based on array list and one based on doubly linked list. Okay. Let's just do this, 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 this. A simple array queue implementation in Rust to do array queue implementation in Rust. A simple linked queue implementation. implementation in Rust. To do linked queue implementation in Rust. And what do we say? This time we'll compare. Now we have a simple commenter that we can benchmark the performance of our homegrown array list and linked list. We've also included benchmarks for a stack based on vec and linked list from the std lib. I've used the criterion lib for these benchmarks. Give that a call out. Also good in case I close my browser and then I can find this link really easily and not forget the name of the lib, even though I've heard of it before. I've never used it. This time we'll compare the array queue, linked queue, and linked queue implementations alongside implementations based on basically Ali. Hey, how's it going? Based on alongside implementation, we'll compare the array queue and link queue implementations alongside implementations based on vec and linked list from the std lib. Okay, love it. I like this. And hopefully we just have a really nice criterion bench output for stack. Criterion bench output for queue. Yeah, me too. I'm excited to do it. I rarely do micro bench stuff. Like we use certain libraries to time stuff at work, even in prod sometimes. But I haven't used it in Rust, so be cool. Yeah, and then we'll just do a little summary. We'll probably want something like say something about benchmarks. And that should inform us on what we want to say. I could rewrite it. This is my hypothesis, right? My hypothesis, we'll write this out. Hypothesis, array stack is faster than link stack. It's kind of obvious, kind of what you'd expect. And the std lib variants are faster than my homegrown ones. Seems pretty obvious. And then array queue is slower than linked queue. We'll see if this is actually true. Array queue based on vec is faster than all. And linked queue based on std lib, linked list is faster than my linked queue and array queue. Okay. Those are my hypotheses. Because keep in mind the linked queue we implemented above uses a doubly linked list based on arc mutex we'll just say arc mutex, which has significant performance overhead. Okay. Oh, you know what would be interesting? Like I have a linked list based on ref cell instead. We could try to throw that in here, but that's probably biting off a little more than I feel like chewing. We could do it, but I think it's a little bit extra for me. Sure. We should probably codify these things. Yeah, it depends on what side quest. We'll see if we have time. We'll see if we have time and how hard Criterion is to get to do with the thing that I want it to do. Arc mutex. Yeah. So, I mean, it's pretty obvious that the studlib linked list is going to be faster than my linked queue. But it would be interesting if the arc mutex actually made the linked queue slower than even having to do a mem copy literally on every insert. And yeah. We're going to do it on insert because I think for my array list, I think we only implemented push front, right? Yeah. We didn't implement pop front. We just implemented push front. Okay. Cool. I'm not going to code all those. Those are just written for my own notes. And it might make it interesting to talk about my hypothesis in the summary. See if the performance matches my... I'm actually thinking the linked queue is going to be slower than even the array queue. I kind of think the overhead of arc mutex is worse than mem moves are. You know? But overhead of arc mutex may be worse than mem move. Okay. Interesting. Let's see. Now for the summary, we just need to copy some boilerplate, if you will. And no, this is literally the reader home. That's not very helpful. Okay, there we go. Yeah, this looks good. Oh yeah, source code with tests. Yeah, so let's just copy all of this. Oh, that's funny. It does that. It's cute though. It's cute. Okay. To catch live coding and data structures. Yep, that looks right. Source code with this is available on GitHub. Now we're actually gonna have two though. So actually, this is gonna be let's say change stack. The source code with tests is available on GitHub. Stack. Q. And benchmarks. All right. And I'm pretty sure this is just going to be in benches based on what Criterion said, just in case I forget. Yeah, benches. Okay. Just in case I forget to edit that link, which I probably will. Stack queue and benchmarks. Cool. Next time we will implement a stack and queue. No, that's not true. That's what we just did. Next time we will implement a ring buffer. Okay. Very good. Ring buffer time. An array-based data structure with constant time access on both sides. Yeah, that deserves an exclamation point. Let's be real. Yeah, I like exclamation points apparently at the next time sentence. That's my favorite apparently. Okay, cool. Let's see. Wow, we're only an hour in. Let's read this real quick. Make sure that I like it. Well, actually do that next time. We do that next time. We already finished. We're so fast. I thought this article might take me a while. But it's a pretty simple idea, right? But I think at least it's a practical use case. Okay. We'll just reread it at the beginning of the next stream like we usually do and go from there. FiFo fum. Oh, that's so funny. Yeah, I could see that. That's good. Okay, and let's just go back. Let it be. I don't want an app. I don't effing want an app, okay? It's not that hard. Okay. Oh, yeah, bye YouTube. You don't need to see this part. Thanks for watching. Like and subscribe. And turn on notifications or whatever people say. Peace.